Good morning, everyone. Today, in this session, I'm going to explain about data preprocessing. So, what is this data preprocessing? It is an important role in machine learning to preprocess the data. The data preprocessing in ML is a crucial step that helps the enhance the quality of data to promote the extraction of meaningful insights from the data. It is nothing but it refers to the technique of preparing, that is cleaning and organizing the raw data to make it suitable for building and training machine learning models. In simple words, we can say data preprocessing in ML is a data mining technique that transforms raw data into an understandable and readable format. A machine has to understand the raw data which can be used given for further machine learning models. So, why this data pre-processing in ML is important? So, when it comes to creating a machine learning model, data processing is the first step. And coming to this real world data, it is incomplete, inconsistent, and inaccurate. That means it may contain a lot of errors or outliers and often lacks some specific attribute values or trends. This is where data pre-processing enters the scenario, and it helps us to clean, format, and organize the raw data, thereby making it ready to go for the machine learning models. So let us now explore the various steps of data pre-processing in machine learning. So these are the various steps of this data pre-processing in machine learning. The very first step is we have to get the data set. So getting the data set and then importing the libraries. Then whatever the data set we have got, that we have to import into a particular model, that is importing data set. And next one is we are going to find the missing data, if any. Not all data sets is going to have missing data, but some chances are there that there might be a missing of data, and then encoding categorical data, splitting data set into training and testing, and feature scaling. Let us describe each and every step in detail one by one. So the very first step is acquiring the data set, that is getting the data set. So this is the first step, and to build and develop any ML models, first we need a relevant data set, and this data set will be comprised of data gathered from multiple and disparate sources, which are then combined in a proper format to form a data set. And this data set differs from one use case to another use case. Suppose if you are developing a ML model for business data set, so it will be entirely different from a medical data set, where business data set will contain relevant industry data, whereas coming to this medical data set will include some healthcare related data. And the second one, the next step is we are going to import all the crucial libraries. So there are three important libraries are required for pre-processing. That is, one is NumPy, Pandas, and Matplotlib. So this NumPy is the fundamental package for scientific calculation in Python. And to insert any type of mathematical operation, we require NumPy. Then next, one more important package is Pandas. It's an open source library for data manipulation and analysis. And it is used extensively for importing and managing the dataset. To make use of import and to manage the dataset, we require this Pandas library. Then one more important is Matplotlib. It is a Python 2D plotting library that is used to plot any type of charts in Python. If you want to do any analysis of data and if you want to represent in the form of a visualization, there we require this matplotlib. Then the third step is importing the dataset. So once we have gathered the dataset, we have to import it into our particular ML model. For that, there is one syntax to import the dataset, that is take any variable is equal to pd dot read underscore CSV. What is this PD? In the very first, when we are importing the packages, we are going to write it as import pandas as PD. This PD is here, pd.read underscore CSV, and URL of the dataset where it resides in the particular system. So this is how we are going to import the dataset. So once we have imported the data set, there are two important things to consider. That is extracting the independent and dependent variables. So what are these independent and dependent variables? Suppose take this data set. This is one example. And here you can see there are 5 columns. 1, 2, 3, 4, 5. And this fifth column is nothing but it is dependent variable. And this first 4 columns are nothing but the independent variable. So we have to extract these independent variables separately and dependent variables separately. For that, we are going to use a function called as ilog function from Pandas library. So that is ilog colon comma colon minus 1 dot values. So this first colon considers all the rows, whereas second colon indicates all the columns, minus 1 is leaving the last column. That means this particular syntax says all the rows and all the columns except minus 1. Except this, remaining all these rows and columns, we are going to display. That is what this ilog function, and this is how we are going to extract the independent variable. And next one is extract the dependent variable. Again, we are going to use the same ilog function. Here colon comma 3. That colon indicates all the rows and 3 indicates the third column. That is the dependent variable. So here you can see the output. That is, in this example, all the rows and this including this column also. That is all the rows of this third column. That is what this ilog function, how we are going to extract the dependent variable. So whenever we upload one's data set, we have to extract this independent variable as well as the dependent variable. And the fourth one is we are going to finding the missing data. So when you see a particular data set, chances are there that where some columns we may see empty columns. That means there is some missing data. So we have to, it is an important role to identify and correctly handling the missing values. Okay, for which there may draw inaccurate or faulty conclusions and inferences from the data. And what are the reasons why data is missing? Maybe user forgot to fill, or data was lost while transferring manually from a legacy database, or there was a programming error, or user choose not to fill out a field about how the results would be used or interpreted. These are some of the reasons why we may find the missing data in a particular data set. And then next one is encoding categorical data. So what do you mean by this categorical data? So see here in this particular data set, this particular column is having categorical data. That is, in terms of strings are there. Remaining all you can see it is in numbers, but this particular country column consists of string data. That is categorical data, where our machine learning model can't understand this one. So we have to convert this categorical data into vectors. That is what this encoding categorical data. So categorical data refers to the information that has specific categories within the data set. So in the above data set, there is one categorical variable, that is country. And machine learning models are primarily based on mathematical equations. So it doesn't understand the categorical data, where we have to convert that into numbers. So for that, that is one step in this one. For that, we are going to use one method called as label encoder, where it is going to convert that categorical data into numerical data. And the next one is very important, splitting the data set into training and test data. So this is the next step in pre-processing. So every data set, whatever we are using for ML model, must be split into two separate sets. One is training set and test set. So training set denotes the subset of a data set that is used for training the machine learning model. And test set, on the other hand, is also a subset of the data set that is used for testing the ML model. And this ML model uses the test set to predict the outcomes. So this is a whole data set you see. This training set can be 70%, test set can be 30%, or else 80, 20, or else 60% of training set, then or else 40% of the training set. So in this way, we are going to split this one. And to split the data set, we have to write the code, that is from sklearn.model_selection. We are going to import train, test, and splitting of the data set. And we are going to use the 4 variables: xtest, xtrain, ytrain, ytest. And test size is 20. 0.2 indicates that is 20% of the data set we are going to use for the testing of the data set. And the last and important one is feature scaling. This feature scaling marks the end of the data processing in ML. And it is a method to standardize the independent variables of a data set within a specific range. So in other words, we can say that it limits the range of variables so that we can compare them on common grounds. And another reason why we need this feature scaling is to get the accurate results. That is also one of the reasons why we go for this feature scaling. So how we are going to perform feature scaling in machine learning is 2 ways. One is standardization, one is normalization. And this is how we are going to do the standardization, where the new value is calculated by x minus mean of x original value, that is mean and standard deviation. Or you can do normalization, where x is the original value minus minimum value, maximum of that minus minimum of x. These are the two methods we use for feature scaling. So when you take without feature scaling, the data set is something like this. Somewhere there is a lot of differences between one data point to other point. So once you do normalizing, it will come into one particular range. And if you do standardization, it will be, the data set will come like this. So compulsory, all the data sets, maybe not all the data sets, at least few data sets requires this normalization and standardization to get the accurate results of a machine learning model. Then let us see the next concept, that is types of data analysis: descriptive, exploratory data analysis, predictive analysis, and inferential analysis. In this, we are going to discuss this EDA, that is exploratory data analysis. So what do you mean by this EDA? It is nothing but the process of performing initial investigations on data so as to discover some patterns or anomalies, or to check assumptions with the help of some summary statistics and graphical representations. So why we need this exploratory data analysis? Maybe detection of mistakes or missing data, checking of assumptions, or preliminary selection of appropriate models, or determining relationships among the explanatory variables. So there are so many types of EDA are there, exploratory data analysis. In that, one is univariate non-graphical EDA. Here, this method involves outlier detection, and we use measures of central tendency like mean, median, and mode, and measures of spread like variance and standard deviation, what we learned in the previous sessions. And this univariate graphical EDA, we are going to use the box plots. We already done, and histograms. These two are the way where we are going to use this univariate graphical EDA. And then next one is multivariate non-graphical EDA. It shows the relationship between two or more variables in either cross tabulation or statistics. So we are going to use to build this statistics covariance or correlation, and then we are going to them assemble into a matrix. And then the last one is multivariate graphical EDA. We use the bar plot, or else we also use the scatter plot. What is this bar plot, scatter plot? We'll discuss in the next session, that is the data visualization. This is also one type of EDA, exploratory data analysis. And the few EDA approaches when we see, we can discuss that dropping the irrelevant columns. Maybe all columns are required for ML models. Some irrelevant columns we can drop. We can rename the columns if necessary. And then we can remove the